Hello, this is Teacher King David. We are still on complex numbers, so now we're going to see modulus of complex numbers. Modulus of a complex number. We're going to see modulus. So modulus is the same as magnitude or size. From how do we get modulus of a complex number? From z equal to a plus bi, which is the algebraic form of a complex number. So the modulus, the notation of modulus here is, this is modulus. So the modulus of z is square root of a squared plus b squared. So that's the modulus, that's how we find the modulus of z. Just the real part squared plus imaginary part squared. Remember, we're not allowed to bring I here because I is not, when we say imaginary part, we mean coefficient of I, not I. We mean the what? Coefficient of I. So it is I squared plus b squared. Examples. Number one, find the modulus of the following complex numbers. Find the modulus of the following complex numbers. We have a z equal to 2 plus I. B, z equal to 3 plus 4i. C, z equal to 1 over 2 plus I to 3 over 2. So we're going to find the modulus of the following complex numbers. We have seen that when you have z equal to a plus bi, so the modulus of z is square root of a squared plus b squared. So now, what is the modulus of 2 plus I as a? What is the modulus of 2 plus I? Because we have a as 2 plus I. So it will be square root 2 squared. The coefficient of I here is what? 1 plus 1 squared. So the modulus of 2 plus I is square root of, that is 4 plus 1, which is 5. So that is the answer. So the modulus of 2 plus I is root 5. That's the answer. B, who can try B? Because our z here is 3 plus 4i. Who can try B? Yeah, the modulus of z is, tell me, the modulus of z is square root of 3 squared plus 4 squared, which is 9 plus 16. So what is 9 plus 16? 25. This is root 25, and root 25 is 5. So the modulus of that z is 5. So which is the answer. C, that one was B. C, we have z equal to a half plus I root 3 over 2. So now, what will be the modulus of this z? Anyone who can help us to do this one? Yeah, the modulus of z is square root of a half squared plus root 3 over 2 squared. So now our modulus of z is square root of a half squared is 1 over 4, which is a quarter, plus root 3 squared, that is 3 over 4. When we add, they have the same denominator. We have to add numerator, which is 1 plus 3, 4. You see, the modulus of z is, that is 1. Square root of 1 is 1. So that is the answer. Let me give you like exercise try. Number 1, as exercise, find the modulus of, we have A, Z equal to negative 3 minus 4i, B, Z equal to 1 plus root 3i, C, Z equal to 5 minus I. 5 minus I. So A is saying Z is negative 3 minus 4i. B, Z equal to 1 plus root 3i. C, Z equal to 5 minus I. So you have to do this exercise. Then after exercise, let us try to see properties of modulus of our complex numbers. We have number 1 here. The modulus of z1 times z2 is the same as the modulus of z1 times z2. Let us try to prove this one by using examples. Let me have an example. Prove that modulus of z1, z2 is the same as the modulus of z1 times z2, where z1 equal to 2 plus 3i and z2 equal to 1 plus I. So now, we are going to see if left-hand side equal to right-hand side. You see our left-hand side contains z1 times z2. So going first take z1 times z2, then you find its modulus. So z1 times z2, what is the answer? The answer is, we just multiply. Our z1 is 2 plus 3i. Our z2 is 1 plus I. So now, what is the answer of z1 times z2? 2 plus 1, that is 2. 2 plus I, that is 2i. 3i times 1, that is 3i. Then 3i times I, that is 3i squared. So now the answer here is 2. 2i plus 3i, that is 5i. 3i squared, that is negative 3, because I squared is negative 1. So z1 times z2, the answer is 2 minus 3, that is negative 1, plus 5i. So now, if this is z1 times z2, what is the magnitude, what is the modulus? What is the modulus of z1, z2? What would be the modulus of z1 times z2? The answer is square root of negative 1 squared plus 5 squared. So which is negative 1 squared is 1, that's the square root of 1, plus 25, which is 26. The answer is root 26.